The South African Mathematics Foundation presents Olympiad Training with Professor Pillay. Don't forget to buy your copy of the Olympiad Training Manual. Go to www.samf.ac.za.
Good afternoon, everyone. Once again, we welcome you to this session, which is meant to train you for the final or for the second round Mathematics Olympiad, the senior round, which I think is going to be written next week, Thursday, the 12th of May. And this will be the last of the 4 sessions which we have been running. So before I proceed, I want to thank you all for coming regularly to these sessions. I presume that since you are the ones who are still remaining at the end of session 4, that you have attended all sessions. While on that, please make sure that you fill the attendance register for the sessions. It will be in the Google Classroom. If you navigate through that classroom, you will find some section which says attendance register, and put ticks across your name wherever at those places where you did attend. It's very important you do that, because then it will boost up your chances of being invited to future sessions. These programs will continue all the way until you go up to grade 12, if some of you are already not in grade 12, so it will be to your advantage. All right. Once again, I remind you that to take your, put your microphones on mute, because when that is not done, we can have a lot of disturbance. I want to welcome my good friend Patrick Rosaberta, who is here with us today, and he is the one who is a project manager for the South African Maths Foundation and one of the organizers of the session. So we must be grateful to him for getting everything on board, on track. All right, I think with those few words, we can start. Last week, we started with the 2021 paper. Oops. Last week, we started with the 2021 paper, and we went up to question 7 or question 8 or something, and we're going to continue from wherever we left off. Okay, now sharing the screen with you. All right, I think this is where we finished. If I recall, I think we did this. What is the difference between the 2 prime numbers that add up to 1 less than the largest perfect cube? I think we did this. I sort of vaguely remember doing that. Okay, let's go to problem 8. Problem 8 says the number 126 can be written as a sum of 2 different prime numbers in several ways. Find the largest difference between 2 such prime numbers. All right, so if you want the largest difference, evidently, you look for the smallest one and the largest one, and that will give you the largest difference. So we look for the smallest prime number and the largest prime number that will add up to 126. So let's just go in a systematic fashion. The first prime number is 2. Sorry, I'm having a problem here. Sorry, I'm having some kind of a problem here. My pen does not seem to be working. Let me just switch it off and come back again. Right, okay. Seems to have worked. All right, so we've got the smallest prime number is 2, and the sum of the two prime numbers is 126. So the other prime number in this case will have to be 124. And that doesn't work because 124 is not a prime number. Let's take the next one. 3 plus 123 gives you 126. That doesn't work because 123, if you add the numbers, you get 6. So that's a multiple of 3. If you look at 5 plus 121, that doesn't work because 121 is not a prime number. It's 11 times 11. The next prime number is 7. That gives you 119. Right? Some of you may think that this is a prime number, but it isn't. It's 7 times 17. Right? So that doesn't work. The next prime number is 11. And you have 11 plus 115. That doesn't work. It's taking a long time to get there. The next one is 13. And 13 plus 113. Okay, that works. 113 is a prime number. So the largest difference is the difference between these two prime numbers is 113 minus 13, which is 100. Okay, so remember, you always see what the question is. We have the prime numbers, you want to work out the largest difference. And the way we did it is you start from the smallest, and that way you will move slowly to the first pair, which works. That'll give you the largest difference. All right, so that takes care of question 8. We'll go to problem number 9 now. Problem number 9 says, Pascal, Newton, Galileo, and Fermat all took the same test. Okay. The average score of the 4 candidates was 16. So they took the test and the average score was 16. Pascal and Newton had an average of 16, and Pascal and Fermat an average of 13, and so on and so forth. All right, so the idea is, obviously, we don't know what these scores were, right? We don't know what they were. So let's give names to them. I like to call them P, N, G, and F. So I can keep track of who is who, right? So the score for Pascal is P, the score for Newton is N, and so on. Okay, now what do you mean by the average? When you work out the average, we have done this before, you add all the numbers and divide by the number. And an important fact is that the average multiplied by the number of numbers that you're adding is actually equal to the sum of all the numbers. Because if you work out the average, you work out the sum and you divide by the number to get the average. So this is important. The sum of all these numbers, since the average is of these 4 people was 16, it must be equal to 16 times 4, and that is 64. Right, so you have an equation. This is the first equation you've got. The second equation is, this is where you take the average of the 4 people, there it's 16. Second equation is Pascal and Newton had an average of 16. So Pascal and Newton, they had average of 16. Now there are only 2 of them. So it will be 16 times 2, that will be 32. And so we've taken care of the second piece of information. It also now says that Pascal and Fermat, their average was 13. So the sum of that will be 13 times 2, while Newton and Fermat had an average of 18. So, which means when you add those two numbers up, you get 36. So the question is, what is Galileo's score? So we don't know what Galileo's score is. But if you look at all these equations, Galileo doesn't feature here at all. Now, very often, I think we have seen this before. It's a favorite trick that people use to solve equations in several unknowns. Because these equations, they all look the same. Right? The trick is often to either add everything or multiply everything. And that usually gives you a new equation, which can be used very effectively, as we see here now. So let's add on both sides. The reason why I say add is, I can see if I look at all those three simultaneously, I've got two P's, two N's, and two F's. So that will simplify quite nicely, because you got 2P plus 2N and 2F is the sum of these three numbers, 32, 36, which is 68, plus 26, that is 94. Okay, which means that simplify P plus N plus F is actually 47, because just simply divide by 2 right throughout, and 94 divided by 2 is 47. All right, now that's very nice, because if I go back to the first equation, it means that's the one that I want to get. But the sum of these other three, I can make G the subject here. That will be 64. The sum of the whole lot is 64. The sum of three of them is 47. Right? So the sum of the last one is 64 minus 47, which is 17. So that is how you calculate this. So to sum up, we got 4 unknowns, and sometimes you get worried. We don't know how to solve 4 equations in 4 unknowns, but with a little bit of ingenuity, you don't have to work out each of those values. Right? You just, by looking at this, you can see that you can get a large part of this one here out straight away. All right, so let's just get on to the next problem. So the answer to this problem is Galileo's score, G, is 17. Okay. All right, so let's just get to the next problem. The next one is, we're going to problem 10. We're still in 2021. We missed 2020. And we said we'll go straight to 2021. If we have time at the end of this, we'll go back to 2020 and do a few problems there. All right, so let's get to the next problem, which is problem number 10. No, problem number 10. The number 2021, so this was the year 2021 in which this was written, is a product of 2 successive prime numbers. 2 successive prime numbers. In other words, prime numbers which are not consecutive but successive. They are the ones which are next to each other if you list all the prime numbers in increasing order. The question is, what is the sum of these 2 prime numbers? Well, those who were in the year 2021 would have known, if you're an Olympiad student, you'll have to know the factorization of the year in which you work. So they would have said 2021, would have known is 43 times 47. I'll come back to that just now. Like you should know that 2022, this is the year, right? This is not very difficult to factorize. If you take out 2 from there, you get 10, 11. And you take out 3 from 10, 11, you'll have 2 times 3 times 337. So just remember the factorization of this. It's easy. Okay, 2 and 3, when you take it out, this is a prime number. Okay, that's important. It's a prime number. Okay, here, if you didn't know this factorization, you'll know they are consecutive. They are near each other. So you have to look at 2 numbers which are quite close to each other, right? And whose product is 2021. And in other words, they are near the square root of this number. So if you sort of approximate the square root, you can see the square root will be 1600 is 40 squared. And the next square is 2500, that's 50 squared. So you are looking at 2 numbers, because this 2021 is in between. So you're looking at 2 numbers between 40 and 50, 2 prime numbers, which when multiplied give you this. And once you decide that, you'll get to that very quickly, because these are prime numbers. So we won't spend any time on that. But the idea is you can logically, using the fact that they are successive prime numbers, approximate what these prime numbers are, because they will be near each other, and which means it's near the square root. The square root is that number by itself, and the square root of this number lies between 40 squared and 50 squared. So therefore, the number itself will be between 40 and 50, these 2 numbers. Once you decide that, then the rest of it comes quite easy. So you have to use a lot of common sense, you know, in problem solving, and argue it out and try to figure out what is the best way to do it. Okay. Problem 11, what is the least possible perimeter of a triangle whose side lengths are consecutive square numbers? Okay, so here you've got a triangle. The sides are consecutive square numbers. Let's understand that now. What do you mean by consecutive square numbers? So the sides of these triangles could be, the first square is 1, 2 squared, 9. So you can have that as a possibility. Or you can have, the next one will be 4, 9, and 16. 2, 3, 4, yeah. Or you can have 9, 3, 4, 5, 4, 5, 6. So these are the possibilities for this triangle. But one very important fact, I think we have said this before, is the triangle inequality. In any triangle, there is a very important property. The sum of 2 sides of a triangle, any 2 sides, is always greater than the third side. When you add these 2, you'll always get a number which is larger than the other side. Now here, this cannot work because 1 plus 4 is not greater than 9. So there is no such triangle. Here too, 4 plus 9 is 13, too small. 9 plus 16 exactly equal to 25. So you can't get a triangle here. And when you try to draw the triangle, you will get all the 3 points will all lie on the same straight line, like this. You got 9. And you put 9 here and you put 16. Right? And this entire line here is 25. So you can't get a triangle. So even that doesn't work, but this does work, because 16 plus 25 is 41, which is, so this is the, why did I do this? We're looking for the least possible perimeter. So you start from the smallest, and so you have to start from 1 and see whether it works, and keep going up until you come to this, because then you know you eliminate all these. So this will have to be the least possible one, because we eliminated all the ones which are smaller, right? So this is a triangle which has sides 16, 25, and 36. And the question is, what is the perimeter? We simply add up all these numbers. 16 plus 25 plus 36 is 77. Right, so it's 41 plus 36. So that's the answer. There are no units given here, so you just leave it as 77. If they add centimeters, you'll have to put centimeters or whatever. So that is how you work problem 11 out. The next problem you're going to do is problem number 12. Problem number 12 says 2 empty containers, P and Q, have the same volume. Oh, all right, so what have we got? Let's just draw these containers. All right, they got the same volume. Water flows into P at a rate of 4 liters per minute. So you've got water flowing into this. We'll call this P, container P, container Q, and you have water which is flowing into this. And it flows into this at the rate of 4 liters per minute. So what is the meaning? Let's just pause with that. So in other words, after 1 minute, this thing goes up to 4 liters. After 2 minutes, it's 8 liters. 3 minutes, 12 liters. For every minute, 4 liters of water goes into this. And as far as Q is concerned, water flows into that at 6 liters per minute, and into Q at a rate of 60 liters per minute. So after 1 minute, this has got 6 liters. After 2 minutes, it's got 12 liters, and so on. So after each minute, Q has got 2 more liters than P. So for every minute, it's got an extra of 2. Okay. Now, after a certain time, container P can still take 60 liters. So it says after a certain time, this thing has come up to a certain point, and it can still take 60 liters. In other words, the amount of space that is left over here is 60 liters, right? And it's come up to that point. The water is traveling here at a much slower rate, and here it's going at a much faster rate. What happens here? And Q has overflowed. Oh, so Q has overflowed. So the water has gone over. So whatever this volume was, this thing has now been overflowing by 10 liters. It's overflowed by 10 liters. So the question is, what is the volume of each container? They both got the same volume, so that's useful, right? And after a certain time, in other words, the time that we are talking about is the same in both cases. So if you say if you say let the time be t minutes. So you have to give names to the unknowns. The unknowns are after how long is this happening? And secondly, what is the volume? But the question is really about the volume. What is that unknown? So we know that after t minutes, after every 1 minute, right, 4 liters flow into P. So after t minutes, you will have 4t liters. After 1 minute, it's 4 liters, 2 minutes, 8 liters, and so on. After t minutes, you've got 4t liters here. So the volume is actually equal to 4t plus 60, because there's still 60 left over in that. So this is the volume, 4t plus 60. Right? I'm not going to write that equation down. If you want, you can put V equals 4t plus 60. But in this case here, after t minutes, you've got the amount of water which has flowed into this is 6t. But that is in excess of the given volume by 10. So if I reduce the total amount of water that flowed into this by 10 liters, I will get exactly my volume. Right? Or otherwise, if you like, you can say the volume plus 10 is 60. The same thing, V equals 60 minus 10. Right? Okay, but now you've got an equation involving one unknown. You can solve this thing here, and I quickly see that t is equal to 35. Right? Please don't ask in the chat how I get this. You can do this. It's a simple equation. And once you got t is equal to 35, then you can calculate V by substituting 35 for t, and you'll get 210 liters. So this is a good example of where you got two unknowns, and you use this information to create equations. But you have to do it in a slow way and see exactly what you are doing to calculate what. So here, because we are given as a rate problem so many liters per minute, and you know after so many minutes, after a certain time, something happens, you don't know what the time is, give a name to that. And then you can get equations, because then you can say after 1 minute, you got 4 liters, after 2 minutes, you got 40, and so on, and create our equations and solve. So it's a good example of where you, good problem solving problem thing, kind of problem that you would or should get in the final examination at your school. Okay, so the next problem is this one. Okay, it's a kind of a long statement of a problem here. In short, you got a game called Killer Sudoku, and what they say is, eventually, if you read all this long story, is that when you add the numbers which are in this boundary, and you got 20, 20 is not the number in that particular square. It's the sum of those 4 numbers, 5 numbers. The sum of these 5 numbers is 20. And likewise, the sum of these 3 numbers is 16. And the sum of these 2 numbers here is 11. And you're asked to say, what is this unknown? But the digits 1 to 9 may be put into these 2 squares. No digit may be repeated in any row or 3 by 3 column. Right? So the number in the left-hand corner is the sum of the smaller squares, which is what I just told you. Okay, so you got So these things are divided into 3 by 3 blocks consisting of 9 small squares. If you played Sudoku, you will know that this is what happened. So this is really the, oops. Let me, this is a 3 by 3 block. And the 9 numbers are inside here. They're not repeated. So how do you find X? Actually, it's very easy. These 5 numbers add up to 20. 1, 2, 3, 4, 5. They add up to 20. These 3 numbers add up to 16. So 8 numbers sum to 36. These 5 plus these 3. But altogether, you got all the 9 numbers here, you see. 1, 2, 3, 4, 5, 6, 7, 8, 9. We don't know where they are. But the sum of the 9 numbers, we know what they sum to. Because it's 1 plus 2 plus 3 plus 4, all the way up to 9. When you add all the numbers up to 9, you get 45. It's a nice thing to remember. The sum of the first 9 numbers is 45. Up to 10, it's 55. Okay. So the sum of all the 9 numbers is 45. 8 of them add up to 36. So the unknown number, which is that one, must obviously be 45 minus 36, which is 9. So we don't use the 13 and the 4 and so on, because we're only looking at this 3 by 3 square in the corner of this board. Okay, so that's straightforward. You just have to know that you've got sums here. So the sum of 8 numbers is 36, therefore the sum of 9 numbers is 45, and the remaining number will have to be 9. A man can commute either by train or by bus. If he goes to work by train in the morning, he comes home by bus in the afternoon. Okay, that's understood. He goes to work from home to the working place. So he'll travel. If he goes by train in the morning, in the evening he comes back by bus. And if he comes home in the afternoon by train, then he took the bus in the morning. In a particular month, the man took the bus to work in the morning 8 times and came home by bus in the afternoon 15 times and commuted by train either morning or afternoon 9 times. How many days in the month did the man work? Looks very, very complicated. Just one moment, please. All right. So you can take the following. In the morning, you can take the bus, or you can take the the train. If he takes a bus in the morning, okay, if he takes a bus in the morning, in the afternoon he traveled by train. So in a particular month, he took the bus to work in the morning 8 times and came back by bus in the afternoon 15 times. Okay, so what does that mean? That suggests that he worked for 23 days. If he took the bus in the morning 8 times and he came home by bus in the afternoon 15 times, because if he is traveling by bus in the morning, he's traveling by train in the afternoon, and if he travels by train in the afternoon, travel by bus in the morning, and he commuted by train, either morning or afternoon, 9 times. Okay, now let me just skip this. This is a very easy solution to this problem, but I can't remember. There was something about each day he either travels, he makes two trips, right? So the number of days, if n is the number of days, right, he will make 2n trips altogether. Altogether, he'll make 2n trips. And then he's got in the morning, he can take the bus. In the morning, he can take the train. But if he takes a bus in the morning, right, then in the afternoon, he takes a train. And if he takes, and in the afternoon, if he comes by train, then in the morning, he's taking the bus. Be like that. Okay, so he took the bus in the morning. In a particular month, he took the bus to work in the morning 8 times. So this is 8. He came back by bus in the afternoon 15 times. So this is 15. Right? And he commuted by train altogether 9 times. So if he traveled x here, then he's traveled 9 minus x here, because altogether it's got that. Okay. So, so the total number of days that he has traveled will be, oh yeah, now I can see what's going on. So how many trips does it make altogether? Okay. Right. So in the morning, he takes the bus 8 times. Sorry, I'm taking such a long time. In the afternoon, he takes the bus 15 times. So I'm putting A, B. We don't know how many times he takes a train in the morning. We'll call it X. But we do know that altogether, he takes a train 9 times. So this has to be 9 minus X. The total number of trips he makes is total number of trips is equal to the sum of all these. And when X minus X cancels, you see, so you'll have 8 plus 15, 23, 32. So the total number of trips he makes is, when you add these 4 numbers, you'll get 32. But therefore, the number of days will have to be half of that. That is the key point. Because each day he makes 2 trips, you see, up and down. The total number of trips is 32. So the number of days will have to be 32 over 2. Okay. sorry, I got stuck there a little bit. So that is how you do that problem. So the answer is 16. Well, let's get to the next problem. A committee has 4 meetings, and at each meeting there are 3 attendees. No 2 committee members attend more than 1 meeting together. What is the least number of members that can be on the committee? See, the problems require a lot of understanding. So you got 4 meetings. Meeting 1, meeting 2, meeting 3, meeting 4. In each meeting, there are 3 people who attend. No 2 committee members can attend more than 1 meeting together. So if you have 2 people attending, suppose you got A and B in this meeting, then you can't have A and B together in any of the other meetings. No 2 committee members can attend more than 1 meeting together. See? So the question is, what is the least number of members that can be on this committee? Okay, so let's just go to my solution here. Now, I've written out the solution here in detail. So suppose you got 3 people in a committee. So each committee has got, so this is first meeting. This is the first meeting in black. Right. Now in the second meeting, you have the first meeting. The second meeting is now in red. And you want to have the least number of people. So you must choose at least 1 from here so that you don't have too many people altogether. So you'll choose 1 from the previous committee, but now you can't choose another one from here. So you have 2 new people. So you got, these are the 3 people in the committee, call it A, B, C. And then here you can't have either B or C, right? No 2 people should come to the committee meeting at the same time. So you have 2 new people. You call it D and E maybe. So now you got A, you got B, C, you got D, E. Now at the third meeting, right, you'll have to use as many people from this meeting, from the other 2 as possible, because you want to get the least number. So let's choose 2 people. You can choose 1 from here, and you can choose 1 from here, right? But you can't choose more than that. So if you choose that, then you got a third, you got a new person, which you need for the third meeting. So far, you got 6 people. And now, the point is, these 6 is quite sufficient. Because for the 4th meeting, all you have to do is to choose 1 from each of these colors, right? And there are 3 of them. So you choose that guy, you choose that guy, and that guy. So you only choose 1 from each of them. And there it is, you have a meeting. And that's the least number. You don't have to have any more than this. So the number of, the question is, what's the least number of people that you need to have altogether in that committee? There are 6 of them, A, B, C, D, E, F. Right? The 4th meeting, you don't need any more. You can use the same meeting, same people. So the answer is 6 participants is minimal. So I've written out the whole solution here in full with that argument. So when you get the solution, when I give you the recording, you can see what the solution is. Okay, let's look at problem number 16 now. Problem number 16, what's going on here? What is the size of the angle that is formed by extending two sides of a regular nonagon? A nonagon is a 9-sided figure. Right? It's a 9-sided figure. And this is regular. It means all the sides are equal. And also all the angles are equal. All the 9 angles, what we call the internal angles. And therefore, even the external angles, right? The supplements of these angles, if you extend these, you get the external angles. They all are also equal. And we have said before that if you add up all the external angles, you'll get 360 degrees. It's a very important fact that the sum of the external angles of any polygon, it doesn't have to be regular, any polygon, always add up to the same number, that is 360 degrees. Interesting, right? So that allows us to say immediately that these 9 exterior angles, they're all equal, and they add up to 360, so each one of them must be 40. All right, now let's see, what's the question here now, as shown. What is the size of the angle that is formed? When you extend these, they meet. They meet somewhere far away. And let me just get into that diagram. And I have done this thing. I got a rather complicated looking picture here. But so far, what we have said is that this exterior angle here is 40. And this exterior angle is also 40. And this is the question. What is x? So one very important thing about any regular figure, right? I don't know whether I've said this thing, but any regular polygon has a center. It doesn't work for random polygons. By center, I mean, which is the center of a circle, containing all the vertices. So there is always a circle that contains all the vertices. I'm not going to go into that. I give a proof of that in my book, 1000 Olympiad Problems, where I deal, I think I've got a whole chapter, a whole lesson on polygons. So you can learn a lot about polygons from there. So there you can see I've drawn a circle here. Right? And then now, once you do that, you can, you know, especially if you're in grade 11 or grade 12, that equal chords subtend equal angles at the circumference, at the center. So all these chords, which are the sides, they subtend equal angles at the center. So if you join all these to the center, you'll get 9 equal angles here. Right? But they add up to 360 degrees. So once again, you get that angle is equal to 40. So the angle at the center is 40. And there's another theorem which says that the angle at the circumference is half the angle at the center, which tells you that if you've got any regular polygon, now listen very carefully to this. And if I join 3 vertices, I can always calculate this angle. If I join any, in fact, I can calculate all the angles, because each side, all you have to do is to say, if you divide the number of sides, if you had n sides in your regular polygon, then the angle at the center will be 360 divided by n. That's how I got 40. And the angle that is subtends at the circumference is half of that, because the angle at the center is twice the angle at the circumference. So at the circumference, you have 180 divided by n. And that's how we get 180 divided by 9 is 20. All right. So bearing that in mind, how do we solve this problem? Okay, so what we do is we join these two. We need to calculate this entire angle here. Also this entire angle here. Now, how do I know, how do I get that? How do I calculate this angle? From there to there. Well, I already got one piece of it is 40. So I need to work out what that angle is. So, and then I'll have to add 40 to that. Now, how do I calculate that angle? Now, that angle is made up of 2 small angles. As you can see, one of the angle is subtended by this side here. So this angle here is 20. Every side subtends 20 angles at every other point. This is what we are saying here. Any side subtends 20 angles at any other point, as long as they are the sides of the polygon. So this is 20. And this is also 20 because you've got a single side here. So this entire angle is 40 from here to here. 20 plus 20. So the whole angle is 80. Entire angle is 80. And you can use exactly the same argument to conclude that this angle is also 80. So then you've got 2 angles of this red triangle. They add up to 160. So the third angle will have to be 20 degrees because all of them add up to 180. So x is 20. Okay, to sum up, let me just say this again because this is very, very important. Suppose I got a circle. And suppose I have, for instance, a pentagon, a regular pentagon, 5-sided figure. It's not going to be very accurate. Kind of will do. Okay, and if I say, what is this angle here equal to? For instance, if I asked you, what is the value of this angle here? Okay. The way you calculate that angle is what I just told you now. You break that angle into, you look at the other 2, you've got 2 there. These are the sides. Join this one here to so these are equal sides. So to get this x here, all you have to do is to calculate these two angles. They're equal because you got equal sides, subtend equal angles at the circumference. But what does any side subtend? It subtends at the center, it subtends 360 divided by 5, which is 72 degrees. So at the circumference, it will subtend 36 degrees. So that is 36, and your x is 72. So that is how you calculate angles within a regular polygon. I'm just telling you that because this fact is used many times, right? Inside regular polygons, how you would calculate various kinds of angles. The fundamental thing is that each side, you know what the angle is that it subtends at the circumference. Okay, I'm using the word subtends and so on, although I'm fully aware that there are grade 10s here. But I think at some point or the other, I must have spoken about these things, but we're not going to spend any more time on that. Now, problem 17, every child in a school has one or more unique numbers with the school's lucky draw. The numbers start at 1 and continue up to 1,000. So each child has got one or more numbers from 1 to 1,000. All right, so the 1,000 numbers are distributed amongst each child. Right? This fellow has got some numbers, maybe one number here, some numbers, but altogether you got 1,000 numbers. Now, what is the probability multiplied by 1,000 that the first number drawn at random as no 7 and no 9 amongst its digits? So this is a probability problem. Okay, so let's just understand this. You got 1,000 numbers. Right? And you want to see how many numbers has got no 7 and no 9 amongst them. So in other words, you can have 565, that's accepted, or 908 is accepted, but 701 is not accepted. Right? And also, no 9, so this is not accepted as well. So the two numbers which are excluded are 7 and 9. So now we need to know, if you want to have the probability, you want to know how many numbers are there altogether which have no 7s and no 9s. That is the question. How many numbers in this set here, 1, 2, 3, all the way up to 1,000, how many of these have no 7s and no 9s? Okay. Now all these are 3-digit numbers except for 1,000, which is a 4-digit number. So let's try to construct such numbers. And you know, my normal trick is I put boxes. Always, whenever I have a 3-digit number, I put a box with 3 digits in it. One for the hundreds, one for the tens, and one. Right. Now, observe that 1,000 is missing. Right? Because, but I can't say 1,000, I can rename 1,000 by saying, we'll call it 000. So the number 000 represents 1,000. Just remember that. Okay, so it's just a renaming of 1,000 so that I only have 3 digits here. All of them. So you have, like for instance, like the number 7 now, right? This will be James Bond. Right? Or 45 will be 045. So we will make every number a 3-digit number so we can allow zeros in the front. But so what numbers are you allowed here? You are allowed 0, 1, 2, 3, 4, 5, 6, but not 7, 8, and not 9. Right? So of the 10 digits from 0 to 9, 2 are missing. So you will have the only 8 possible ways in which you can fill this box. Oh, I messed it up. Anyway, there are only 8 possible ways in which you can fill the hundreds. Sorry, it's very untidy. Okay, there are 8 ways in which you can fill this box. Likewise, there are 8 ways in which you can fill this box, and there are 8 ways in which you can fill this box. Right. So the question is, how many ways, how many such numbers have you got? Now, I suspect that we have done this thing. Let me just give a small lesson here quickly. I don't know whether I've done it. I can't remember. I have so many classes, I'm not sure what I do where. Okay, there's a very important fact. It's called a counting principle. First counting principle. It says that if there are m ways of doing one thing, and n ways of doing another, then there are mn ways of doing both together. And let me explain what this means. Sorry, my writing is far from clear. My favorite example is where I got, suppose you got 3 towns, let's call it A, B, and C. And there are 3 roads which lead from A to B, and 4 roads which lead from A to C. Then how many ways are there? How many pathways can I have from A to C altogether? Right? You'll see that there are 3 roads here, the 4 roads here. The logic is, for each of these roads, if I choose any one of these roads, right? Choose that one. You got 4 ways in which you can get to C. For this road, you got another 4. For this road, you got another 4. So the total number of ways will be, for each road, there are 4 possibilities. Therefore, for 3 roads, it will be 3 times 4. So there are 3 ways of doing one thing, and 4 ways of doing another. And the number of ways of doing both together, that means you go from A to C, is 3 times 4. That is m ways of doing one, n ways of doing another. It's like that. And if you had even a 4th town, and you have several roads going from there to there, let's say maybe 5 roads, then the total number of ways you can go from A to this is 3 times 4 times 5. See? Because you can find 12 ways of getting from here to here, and then for each of these, there's 5 of that. So that's the logic. For each one of these pathways, you have so many of the others. So altogether, you have to multiply. Right. Now, why did I do all this? The reason I did that was because in my problem, I have to choose these numbers. I have to choose these numbers. And this is very much like the roads problem. Right? You say, my units digit can be chosen in 8 ways. Start here. You're not allowed to put 7 and 9. Having chosen the 8 unit digits, for each choice of the unit digit, I have 8 ways in which I can choose the 10th digit. So there are 8 times 8 equals 64, in which I can choose the first 2 digits. And for each of these 64, I have 8 ways in which I can choose the 100th digits. So the answer is 8 times 8 times 8. Just like we got there, 3 times 4 times 5, and that is 512. So there are 512 numbers which have the property. Remember, the 0 is also excluded because 0 is amongst these 512, right? Because it doesn't have a 7 or a 9. Okay, so altogether, you got 512 out of 1,000. Right. The question is, so the 512 numbers out of 1,000, which so they say, what is the probability multiplied by 1,000 that the first number drawn has no 7 and no 9? So it's 512 over 1,000 times 1,000, because the probability is 512 over 1,000. That's the chances of picking a number which has got no 7s and no 9s, because there are 512 such numbers. So the chances of picking one of them is 512 in 1,000. That's the probability. And therefore, the question says you must have to multiply that by 1,000. So the answer is 512. Okay. The next problem. Says that 2 squares are inscribed differently in the same isosceles right triangle as possible. I mean, as shown. So you can see you got 2 right angle triangles there. We didn't show the right angle, but certainly have. The right angle triangle. There's a square drawn like this. There's another square drawn like this. And the question is, okay, if this is done in the first figure, then one finds that the area of the square is 441. So the area of the square is 441 here. The question is, what is the area of the square in the same triangle as shown in the second figure? All right. So what is the area of this square? So let's give a name to this. Suppose we call this X. The square here, the side, we call it X. Now remember, it's an isosceles triangle. There's a 90 degrees here. And you call this an isosceles right angle triangle. So these are equal. So both of them are equal to 45. And this is also a square here, so this is 90 degrees. So this is 45 also, because 90 degrees, that is 45, this has to be 45. But now this small triangle is isosceles, so that becomes x. So in this square here, the side is x. So this part here will also be x. And this will also be x here because this is a square. And again, you got a 45 here at the bottom. So this will be x. Right? So now, so you've got the in this situation here, you've got this area here is 441. So 441, by the way, is 21 times 21. So the area is 441, and so this is a square. So the same argument will give you 21, 21, 21, 21, like that. Okay. So which means I can actually calculate the hypotenuse of the same triangle in two different ways. On the one hand, it is, oh, this is also 21 here. So this is a square. So that's how it is. Okay, so the hypotenuse, if you use Pythagoras, that means this thing here is 3x now. Because we just saw, if your side of the square is x, then the hypotenuse is 3x. And there you have it. You have a two sides of a right angle triangle, and you're trying to calculate the hypotenuse, and you have an equation. Square and the hypotenuse, 3x all squared, is the sum of the squares on the other two sides. So this is 42 here, so it's 42 squared plus 42 squared. With this thing here, the sides are 42. Each side of the small square is 21. And there you can solve for x. Okay, you just needed x squared. You needed the area of this. So you need not square, work out the x itself. You needed x squared. So x squared would be, you have to divide right throughout by 9. So if you divide this by 9, you're taking out 3 squared. So you're left with 14 squared plus 14 squared. Just think about that. When I'm dividing this by 9, I'm dividing by 3 squared. So I'm left with 14 squared. So this is easy to calculate. 196 plus 196 is 392. And that is exactly what we're looking for. The area of the square here is x squared. And the answer is 392. Okay, I took a little while to do that, but the starting point is we don't know what the area of what the side of the square is. Right? So let's start there and use all the information to get as much information as possible. And you see, to your satisfaction, that you can actually calculate the hypotenuse. It will be 3 times the thing. And in this case here, the hypotenuse is twice the square. Right? Well, not quite. But anyway, you can calculate the sides of the square, and therefore you can get an equation. All right, see, you'll notice that in problem solving, I go in it piecemeal. I take each piece of information and I try to see what I can gauge from that, try to get as much information as possible, and then go on. I don't read the entire question. Sometimes I do. right? Like now I need to know what is the area of the square inscribed in the same triangle. So I needed to know that question. Okay. All right. So that takes care of problem 18. And we go on to problem 19. I had a much nicer picture here. But anyway, problem 19. These problems become more and more difficult as we go along. In a chess tournament, each of 8 participants plays one game against each of the others. So there are 8 participants. And so if you just list those participants, each of them plays one game against the others. So the first question is exactly one game. So how many games are played altogether? Well, there are 2 ways of doing it, but I think the easiest way is you've got 8 participants. To find out how many games are played altogether, you have to count. Each game is played amongst 2 people. So a game, instead of counting the number of games, you count the number of pairs of people. Every pair plays one game, and each game is amongst a pair. So you want to know the same question, how many games? The same question is, how many ways can you choose 2 participants from 8? And we've seen this before. The number of ways of choosing 2 objects from n objects is n into n minus 1 divided by 2, and that gives you 28. Right? So I'm not going to revise that. We have done this before. So the number of ways of choosing 2 participants from 8 is 8 times 7 divided by 2. And that is also equal to the number of games, because instead of counting the number of games, you count how many ways can you choose 2 people. Right. Okay, so that's the first sentence. A win is worth 1 point, a draw half a point, and a loss 0 points. Now, at the end of the tournament, each of the participants has a different total score. So the 8 people, they get a certain score because each one plays so many games, and each one plays 7 games actually. They play everybody else, and they have a total score. The maximum score you can get is 7 because each one plays 7 people, and the highest score you can get is 7. A draw is worth half a point. Right, now, but they all got different scores. That's important. The total score of a participant in the second place is equal to the sum of the scores of the bottom 4 spaces. All right, so we have to rank these players, right? Player 1 up to player 8, highest to the lowest. And then you can see what the second one is. And then you look at the bottom 4 and you add the bottom 4 is equal to the sum of the scores of the participants in the 4 bottom squares. Right. Okay. So that's piece of information is given. If the participant in the 8th place, in other words, the last person, drew 1 match and lost the rest, right? So you know his score. Because the last person, he drew 1 match, you would have got half a point for that, right? But he lost the rest. So he got zeros for the remaining 6 games. So his total will be a half. Right? The question is, what is the maximum score of the participant in the 5th place could have achieved? So it's kind of a tricky, complicated kind of a problem. But let me just go through this thing. I've explained what this thing is, and I've drawn a table here. All right, let me explain what I've done here, and I'm going to go through this thing. So I'm just bearing in mind scores are different. The second is the sum of the lowest four. Eighth drew one match and lost the rest. Maximum score, you want to know what the maximum score of the person in the fifth place. So for that reason, I give the name X to number 5, and I want to know what is the largest possible value for X. That is the question. All right, now let's see what I've got in the rest of the table. All right, we said that the first score, the lowest score was a half. So we know this guy has got half. Now, you want the maximum value of this, which means that you want the sum of the remaining numbers to be as small as possible, the remaining 7 numbers. So we will try to make all the numbers as small as possible in order to get the largest value for X. So that's very important. Because we know that all the 7, 8 numbers, they all add up to 28. When you add up all these things, you're going to get 28. No, there were 28 games. 28 games. Oh, yeah. Right. 28 games. And each game, what's the score in each game? That's interesting. So there's a game. You got 2 players. Player 1, player 2. Right? If player 1 won, this guy got 0. If player 1 lost, that guy has got 1. And if they drew, they both got half. So the interesting thing about this is that each game, the total score in each game is 1. Right? So the total score in each game is 1, and there are 28 games. So therefore, the sum of all these scores here, these are the scores, when you add them, you're going to get 28. When you add all these scores. Because these are the scores. These are the scores of each person, and the total score, I'll repeat that. Why is the total score 28? Because the total score is 28 because there were 28 games played altogether, and the total score in each game is 1. There are 2 people playing. We don't know what the scores are. It could be 1, 0, 0, 1, or half, but the total score for each game is 1. There are 28 games. So and these are the scores for each person. So that means when you're adding up all these, you're going to get 28. You want to get this X to be as large as possible. So you want these to be, the rest of it as small as possible. So that is why I put a half here, and then I make this 1, because they're all different, right? Right? I want to make this as small as possible, and this is 1.5, right? And now we've got X here, and they say the sum of the lowest 4, X, 1.5, 1.5. Now that's the lowest 4. If you add them, you got 1.5 plus half is 2, 2 plus 1 is 3. So the sum of the lowest 4 is X plus 3. And that is the score of the second person. So you can see, I got X plus 3 there. So that explains all these guys. And then from that point onwards, I want to make this as low as possible. X plus half, make that as low as possible. X plus 1, and then go to X plus 3. And we don't know what that is. Right? We don't know what that is, but what is important is that when you add up the whole lot, you're going to get 28. Right? So let's add up all these numbers and see what happens. You want X to be as large as possible. So your Y plus the 4 X's. And you got 3 plus 1 is 4, 4.5. Plus 3, 7.5. That's equal to 28. Okay, so we need to solve for X. So 4X So when you bring this to the other side, you got 20.5 minus y. Right. So you want to know what is the largest possible value you can have for y, for x. Now, bear in mind that y is greater than x plus 3. Right? So, bearing that in mind, y is greater than x plus 3, greater. So, minus y, if you change the sign, that's less than minus x minus 3. So 4x equals 20.5 minus y. Right? And that is less than 20.5 minus x minus 3. The minus y is less than that. So that gives you 17.5 minus x. Okay, so if you look at that now, you got an inequality involving x. Okay, it's not very clear. Sorry about this. My whole writing board is gone upside down. 4x is less than 5x. 4x plus x if you bring it to the other side. Is less than 17.5. So the largest possible value you can have for x is 3. Because these numbers can only be a whole number or a whole number and a half. Right. So you see x is less than 3.5 when you solve for this. Right? And the largest number, which is less than 3.5, is 3. Right? It has to be a whole number or a whole number and a half. So that's the answer. The largest possible value for x is 3. Okay. Now you can see this is rather difficult, but you can see it's this mathematics. There's pure mathematics involved in this. Although there are 8 different unknowns, somehow we brought those unknowns into just 2 unknowns, which is very beautiful. Right? Using those informations and talking about making sure that the sum of the others is as small as possible, we can actually write down what these scores are from one to the other, as we have seen, right? And yeah, so whatever this y is, it must be greater than we have ranked them from 1st to the 8th. Okay, so that is the solution to that problem. Problem number 20. Here you got a rather complicated looking sum here because you've got, let's see, you got 60, find the value of the 66 times. You got 1 plus 2, 1 plus 3, going all the way up to 21. So it looks as if we've got 21 fractions which are added. Now that's quite frightening. You need to add 2 or 3 fractions. You must find the LCM and so on and add them. 21 fractions. If you do it the conventional way, then you will have to work out the LCM of these numbers and add them and multiply that by 66. It looks like an extremely difficult problem. But if you use mathematics, you will see how this thing works out so nicely. I'm going to show you how. You see, for one thing, we have a formula for the sum of the first n natural numbers. Sum of the first n natural numbers. 1 plus 2. Natural is counting from 1, 2 up to n. And we've said this many times. This is n into n plus 1 over 2. Every Olympiad student must know this. right? The sum of the first natural numbers is the last one times the next one divided by 2. So we can do that here now. This part here is, okay, this is, I'm not going to calculate this. I'm just going to say that this is 2 times 3 divided by 2. And you can see that is 3. 1 plus 2 is 3. But I'm using the formula. This is 3 times 4 divided by 2. I won't simplify. 4 times 5 divided by 2. You can see 4 times 5 divided by 2 is 10. 20 over 2 is 10. And when you add this, you get 10. Going all the way up to, this is not so easy, but this is 21 times 22 divided by 2. And you can get the answer straight away. So the denominators all look like this. They are fractions like this. So if I simplify this, I can put 1 over 1. I'll put 2 at the top now because the denominator has got 2 times 3 divided by 2. So I'm going to put 2 at the top and put 2 times 3 at the bottom, plus 2 at the top, 3 times 4 at the bottom, 2 at the top, 4 times 5 at the bottom, going all the way up to 2 at the top, 21 times 22 at the bottom. I'm trying to look for some easy way of solving this problem. All right, I got all 2's at the top there, so I might as well just, I don't have 2 yet, so let me just make this in 2 over 2 as well. Okay, so one is 2 over 2. And you can see the pattern, 2 over 3, so this is 1 times 2. So now you've got all 2's at the bottom, so you can take the 2 out of the top and you get 132. And then you got numbers like this. And the general number is a number times the next one, n times n plus 1. So all these numbers of the form n times n plus 1, the denominators. Now, what are the values of n? We just make sure we know what the values of n are. N starts from 1. You can go from 1 times 2. So 1, 2, all the way up to 21. Right? The last value of n is that one, 21. Okay, so now you have that all these terms, they look like this. Now watch. I'm now going to go into the next page. And I'm going to analyze this object here. Each term, which has got 1 over, which looks like this, I'm going to write a little formula here, which is not very difficult to see. Why didn't I? Sorry. Okay, I didn't write the formula down. Now watch. If you take 1 over n and subtract from it 1 over n plus 1 and simplify this, and that's easy. That's simple algebra. You'll have n into n plus 1, and here you have n plus 1, and here you have n. N plus 1 goes into this. And you will see that you got 1 over n into n plus 1. That's exactly what we are talking about. So what does this mean? That every term here, every term which I wrote down, these terms, can be written as a difference of 2 numbers. Like for instance, I can say 1 over, say, 14 times 15, for example, that's n is 14, 14 times 15, is 1 over 14 n is 14, minus 1 over 15. So if you simplify 1 over 14 minus 1 over 15, you'll get precisely that. This formula works for any n. I can put n equals 14, and you'll get that. Right. So there's your n in 10 plus 1. So observe, 1 over 14 times 15 is 1 over the smaller one minus 1 over the larger one. So if you take this, it's 1 over 1 minus 1 over 2. This is 1 over 2 minus 1 over 3. This is 1 over 3 minus 1 over 4. Remember, this is where we stopped. We had a 132 here, and we did this. And this last one is 1 over 21 minus 1 over 22. And now watch, magic. Because you've got a minus half plus half. Those two annihilate each other. What I call commute fratricide. Brothers kill each other. Then you got minus 1/3 plus 1/3. They cancel. Likewise, minus quarter will cancel off the next one. And this guy here will have been destroyed by his predecessor. So the only survivors in this thing here, all these things cancel off, are the first term that's not killed and the last term is not killed. And you get 1 minus 1 over 22. And that's very easy to calculate. You just multiply 132 times 1. And 22, of course, you can see why 66 occurs there. The 22 goes exactly into 132. And that is 6 times. So the answer is 126. So this is a very, if you haven't seen this before, you will have problems in working this thing out. But just remember, when you got 1 over a product of consecutive numbers, you can have other kinds of things as well, and you can still do the same thing. You might have 1 over n into n plus 3, for instance, right? And there too, you have to do some juggling, and you can work out this thing here as a difference of 2 numbers, just like what we did here, right? There you will try to calculate 1 over n minus 1 over n plus 3. You won't get that, but you can still get something close to that. So you can write this in terms of this, which will help you to solve the problem. Okay. Okay, so that takes care of problem number 20. So we're now at problem number 21. Okay, the lengths of the legs of a right triangle. Right triangle is a right angle triangle. Sometimes some people call it right triangle. You should call it right angle triangle. Otherwise, you'll have a right triangle, a left triangle, and a wrong triangle. Okay, so it's a right angled. Having right angle at D, the length of the legs. So these are called legs. So one of them is 18, which is that smaller one to be 18, and this is 63. What is the radius of the circle that is tangent to both legs? Oh, that's what we got. You got a circle which is tangent to both the legs, and its center is on the hypotenuse. The question is, what is the radius of the circle? Okay, so let's just see where the radius is in this picture. So we know the circle touches these two, and you know the lengths of those two sides. The question is now, what is the radius? Okay, there's a center. So I know that if I join the center to the point of contact, I get a right angle. So let's do that. That's obviously the place to start. And more than that, that becomes a radius. There's somebody called Sophia, I think. Your mic is on. Please take it off, Sophia. All right, now, so this is the radius. Of course, the radius of a circle are all equal, so that will also be the radius. And this is 90 degrees, the right angle triangle. The radius is perpendicular to the tangent, so that's 90 degrees also. So you actually have a rectangle. More than that, it's a square because all these are equal. The two sides here are equal. So this is also R, and this is also R. Okay. All right, so that allows you now, you got this entire length here is 18. So that allows us to, let me just take this thing out here. And just bear in mind, the full lengths are 18 and 63, which means that I can work out the other part. This part here is 18 minus R. And this part is here 63 minus R. Right? So the problem is, what is the radius? That's your unknown. Now, we're going to try to get an equation here. You might say, well, you've got a right angle triangle. So let's work out this part here and work out this part and add them and square them. And then you got the square of the hypotenuse, and that will be 63 squared plus 18 squared. That'll be a good idea if you do that. And then you get an equation. 18 squared plus 63 squared is equal to that plus that all squared. The only problem is that you've got a square root object here and you've got a square root object here, and you're adding those two square roots and you're squaring that, and it becomes a very cumbersome thing. Right? It'll take a long time to get there. But there's a very, very simple and easy way of doing this thing using either geometry or trigonometry, either geometry or trig. The reason being that this big triangle here, that angle there is equal to this angle here, because these lines are parallel. So these are corresponding angles. And likewise, this angle here is equal to the angle there. They're also corresponding angles, which means that these two triangles have got the same angles. And when two triangles have got the same angles, then I always say that one is just a photograph of the other, right? If you know the sides of one triangle, the other one, and if you know one of the sides of the other triangle, you should be able to calculate all the sides because they are in the same proportion, right? Now, what do I mean by that? Like, for instance, if I take this side here, 63 minus R, in this triangle, and I put it over the side here in that triangle, both of them are opposite cross, they got the same angle. That'll be equal to the stretch, the thing that makes, what must you multiply this by to get that? It's that amount there. So it's the same. So in other words, the ratio of this is to this would be the same as the ratio of that, R, over 18 minus R. It will be the same as this over that, because you have to multiply all the sides by the same number, right, to get to the other one, which translates into ratios as the ratio of the corresponding sides are the same. They say the corresponding sides are in proportion, the same proportion. Corresponding means 63 minus R corresponds to R because both of them are opposite cross, and likewise with the other one. If you don't like that, you could have said, use trigonometry. These two angles are the same. So the tan of X in that picture is 63 minus R over R. In this one here, the tan of this angle will be equal to the tan of this angle here, which is R over 18 minus R. opposite over j, because these angles are equal, you see. They're exactly the same thing. And so you could use geometry, similar triangles, or you could use trigonometry, which is even easier. But I didn't want to do that because the grade 10s. Now, where did this guy come from? So there it is. You have an equation involving r, and you can solve for r. I'm not going to do that because we don't have time. But the whole idea is to get to an equation, and thereafter you can solve, and you can do that. That's just for academic purposes. So let's just get on to the next problem. So, so that is how you solve the problem. Observe, what we did there was we joined the center to the points of contact, because we know that we can use the radius tangent theorem there. At the same time, when you join them, you have two radii, which you need. So it's very useful to join them. Good reason to perform that construction. The next problem. Joe has 20 liters of each of two different solutions of salt. The concentration of solution A is 20%. And these problems, usually people, they get really stumped with this thing, because the reason for that is they don't use the words. The words that are used, you have to, unscramble the words so that you understand the meaning of it. So you got two different solutions of salt. And it's got 20 liters of each, right? Okay. So what happens now? Okay. The concentration of solution A is 20%. Now, what does that mean? It means that in solution A, we've got A and B. Let's just name these things. So let's look at this first solution. But concentration means you got 20%. That means the amount of salt, the percentage of salt is 20%. %20 of the whole thing. See? So it means that 80% of it is water and 20% is salt. So the ratio of water to salt, if you like, is 4:80:20, which is 4:1. So that is how you translate. This is your salt. Right. Then you've got solution B, the concentration is 45% more. So the amount of salt here is 45%. Okay, how many liters of solution B must be added to 10 liters of solution A to obtain a solution with concentration 30%? So you're going to add 10 liters to this. You're going to add 10 liters of solution B. Oh, I'm sorry. 10 liters of solution B to, you got 20 liters altogether. All right. So you take 10 liters of this solution. How many liters of solution B must be added to 10 liters of solution A? All right, so I take 10 liters of solution A. Let's just get that mixed up here first. Let's look at 10 liters of solution A. Now, 1/5 of that is salt, 20%. So in solution A, you have This is 10 liters. So in this, you got 2 liters of salt. 20%, right? 2 liters of salt. Okay. Now you're going to add X liters of solution B. We don't know how much of solution B you're going to add to this quantity here. So that the new concentration is 30%. All right. I've put everything here into a single diagram, and you'll see what I'm doing here now. Right. So originally you had 4 salt and 16 water. I should have done that right from the beginning. 20% is 4 and 16 here. And your 45% is 9 over 20. So it's 9 salt and 11 water. So that's what you got. And then you're taking now you're taking 10 liters of this, right? Which means I've got 8 in this new scenario here. You've got there were 20 liters originally. Now you have 8 liters of water and 2 liters of salt. That's what you had, 10 liters of solution A. Now you're adding this stuff here. So you're going to add 20, you're going to add some part of this, right? But you are taking X liters of this. So if you take X liters and mix it up properly, so 1 liter contains 9 of salt. I'm sorry, 20 liters contain 9 of salt. So 1 liter will contain 9 over 20th of salt, and X liters will be 9X over 20. Let me just write this thing down. So you got 20 liters. It's got 9 salt. Now I want to get X. I'm sorry, X liters. How many salt? Right? If you want, you can say, well, it must be X over 20 times 9. The fast people will do that. The other people will say, well, X liters contain how much of salt? So you see 1 liter, we already know 1 liter has got 9/20th salt. So therefore X liters will be 9X over 20. So that is how you got the X liters has got so much of salt, and the X liters have got so much of water. It will be 11X over 20. So this is your new situation, and you want this concentration to be 30%. Now, what does that mean? The total amount of salt you've got here, which is 9X over 20, let's add that salt there. Right? Where is the salt? The salt is here. So the total amount of salt is 9X over 20 plus 2. The concentration of that will be that divided by how much do you have here altogether? You've got 30, because you've got 10 liters of this. No. You got 30 plus X, 10 plus X, sorry. You got 2 plus 8 is 10. And when you add this, you're adding X new quantities. So your original 10 is now becomes 10 plus X. So this will be your new ratio, the concentration of salt. But if you want that to be 30%, you must translate that into a fraction. 30% is 3 over 10. And then you now have your equation. You have your equation because this is the total amount of salt over the total amount of liquid in this, and that new concentration is 30%, and you can solve for X. Okay, I'm not going to do that there. And as I said, these problems get quite difficult. This particular one, the next one here, is very difficult actually. So I'm just going to skip that. But what I'm going to do is show it to you on the screen. So you can have a look at that. So you can try it out on your own because I've got the whole thing written up. Or maybe what I have to do is to give you the full solution. Okay, I will. Oh, there it is. There it is. So if you keep going on, you can see it's very complicated. And the geometric sequences come up in this problem. So I've got this thing all exposed. So when you get the recording, you can pause it here and think about what's written and read it and try to see whether you can understand it. That's problem number 23. Problem number 24. Triangle ABC in the figure has area 450. So the whole triangle has got area 450. The points D, E, and F, right? They all lie so on and so forth. But the ratio of AD to DB is 2/3. The ratio, remember, you don't say 2 and 3 here. You'll say 2x and 3x. Like that, that's the ratio. The actual number will be 2 times something, and the number here will be 3 times the same thing. Right? That's how you treat ratios. Triangle ABE and quadrilateral DBEF. ABE, I'm just going to shade this triangle so you keep track of it. This triangle ABE and quadrilateral DBEF. So you got DBEF. Let's say I've got the same area. So DBEF has got a part of it is red, and there is another part here. Like that. So they got the same area. If you think about this, you'll see that the red part and the DBF is the blue plus this red piece, this quadrilateral here. So actually, you got these are crossed here like this. So the blue and the red are the same, which means that I can remove this quadrilateral out from both of them. And this triangle and this triangle will have to have the same area, because this triangle plus this quadrilateral has got the same area as this triangle plus the same quadrilateral. So if you remove this quadrilateral from those two, you'll get that these two triangles have got the same area. Now that's very interesting, because it means you got two triangles have got the same area. So what does that mean? If you look carefully, you'll see those two triangles actually have got a common base. But first, I'm going to erase this part here. So those two have got the same area. And these two triangles, well, they don't really have the same base. Let me see. I can put, if I join these two have the same area. The red and the blue are the same. But you can add to both those areas this little triangle, which is green. So you can say blue plus green is equal to red plus green. And now you've got two triangles. This triangle here, that triangle, I've got the same area, but they also got the same base. I've created a base, a common base for those two triangles. Now, if you got two triangles have got the same base and they got the same area, the conclusion is that they must have the same height, because the formula for the area of a triangle is half base times height. So it means that this triangle has got the same height as this other triangle. What does that mean? Now let's just see. I'll draw a height. This blue plus green. I'll draw the height here, 90 degrees. And this triangle here, the height is, if I extend this thing, I'll have a height like that. So it means that these are equal. But if two lines, that means these two lines are equidistant apart. This line is equidistant, right? This is equal to this, which means that this line must be parallel to it, because the distance from here to there at this point is the same as the distance from there to there. So these two lines are parallel. See? And now the mean proportion thing comes through. Because if this is 2x and this is 3x, and you got these two lines are parallel, right? Those who are actually, it's common sense. If I got a triangle and I got a line which is parallel, then they must divide these two in the same proportion. If I got 2 and 3 here, then I will have 4 and 6 here, or 6 and 9, or whatever, right? On this side, because it's a theorem in geometry, but they got the same ratio. So if this is 3x and this is 2x, this one here will also be 3y maybe. And 2y, right? Now at last we can say this whole triangle has got area 450, right? This triangle from here to here, right? Its area is the ratio of the areas of these two triangles. The sum is 450, these two triangles which I'm looking at. And the ratio of their areas will be the same as the ratio of the bases, because they've got the same heights, you see. So when you work out the area of this triangle, it's half base times height. And here in this triangle is also half base times height. So if you put one area over the other, they got the same height. So it will be the halves cancel, and it will be the same as 2 over 3. So triangle ABE, that's the area that we're looking for. Triangle ABE will be 3/5, because this is 3 and there is 2, and altogether the entire triangle is 450. So this triangle here is 3/5 the area of the large triangle, while the other is 2/5 the area. And when you work this thing out, you get 270. That's the area of ABE. That's what we wanted. What is the area of each one of them? So it's quite a deep problem. And it uses mean proportion and areas. If two triangles, an important fact is whenever you got parallel lines and you got two triangles which have got the same base in parallel lines, they all got the same area. Very important fact. All these triangles have got the same area as long as they got the same base. Because they got the same height, you see. Therefore, they will have the same area. And conversely, if they got the same height, they will have the same area. That is what I was using here. So those triangles have got the same area, and then therefore the lines are parallel. All right, so that's almost there, and I just want to see what I've got here. Okay, I still have a few people who are yet 37 people. I'm going to do this last one. Determine, so you got, if n factorial is 1 times 2 all the way up to n, determine the largest positive integer n such that 1005 factorial is divisible by 10 to the power of n. You know, one of the most difficult things in all these problems is to understand the question. Okay, so it takes a while. So just have a look at it, draw a piecemeal. You're looking at 1005 factorial. So let's just see what is the meaning of that. Now, it's n factorial is, well, we've seen this before. I'd rather put them starting from 1. 1 multiplied by 2, all these are being multiplied. 3, I'll rather put down. Times 4, times 5, all the way up to 1005. This is a very, very large product. That's 1005 factorial. Now the question is, determine the largest positive integer such that is divisible by 10 to the power of n. So you want this thing, you want 10 to the power of n to go exactly into this monster. Right. For it to go exactly into that monster, 10 to the power of n, if you break it up, you got 2 to the n times 5 to the n. Right. So if you want 10 to the n to go exactly into this, it means that 5 to the power of n goes exactly into this. Right? Now, so what is n? If 5 to the n goes, well, you can say 5 itself goes exactly into this. 1005 goes into this. But what is the largest possible n? The question is the largest. Right? If I pull out all the 5s, how many 5s have I got? That is the question. See? Well, now that involves a bit of counting. So the question is, how many 5s? Are there? Let's answer that question. Later on, we'll take care of the 2s. Right? In this product, in the product. So you must take out the largest possible power of 5. Okay, now we can start counting them. You got a 5, 10, 15, 20. All these have got 5s in it. 15 has got 5 times 3. 20 has got 5 times 4. And 1005 has got also a 5. So how many 5s are here? Well, you can't count it because this is 5 times 1, 5 times 2, 5 times 3, up to 5 times 201. So there are 201 5s in this product. 5 times 10 times 15 and so on. Right. But one must be careful because some of them have got 2 5s, like 25 We only counted it once, yeah? But you have to count it again because this is 25 has got 2 5s in it. Not only 25, but all the multiples of 25. 25 times 2, 25 times 3, all the way. And the last 25 you have before 1005 is 1000. Now this is 25 times 1, 25 times 2, 25 times 3, and this is 25 times 40. So there are 40 more 5s here, which we didn't count. Right, so we can sit back happily and say, oh, right, okay, I've taken care of it because I nearly miss it. You know, I've got 25, I've got 2 5s, and I only counted it once. Then you say, well, wait a minute, that's all of them which have got 3 5s. We didn't count the third 5 in 125. And this has also got all the multiples of 125 have got 3 5s in it, going up to 1,000, and there are 8 of them. So they got 8 of them have got 3 5s in it. We must add those extra 5s. And if you multiply this by 5, you got 625, so 5 to the power of 4. One of them has got 1 5 in it. And that's the only one which has got 4 5s in it. Because after that, when you take multiples of it, they are more than 1005. You only need to go up to 1005. So the total number of 5s you got here is you have to add up all these things. And you get 250. There are 250 such 5s. So you got this, in other words, this is equal to 5 to the power of 250 times something else, right? Now we need at least 250 n's to get 10 to the power of 250. Right? So each 5 is paired with 2 to get a 10. So to get a 10 is 10 times 10 times 10 times 10, n times. And these 255s, right? If you pair them off with 252s, then you'll get 10 to the power of 250. And obviously, you can't get anything more than that because you only got 255s. Okay. Right. Now the question is, are there 252s here? Yeah, definitely, because there are lots more 2s than 5s. If you got 255s, you got many more 2s, right? So you got at least 250 2s. So therefore, your n is 250. I remember when I did this thing, I thought I had the answer 249 for some reason. I can't understand why. Now, maybe I didn't count it properly. Okay, so that takes care of problem number 25, guys. Thank you very much, because we've taken another 17 minutes of your time, and we've just finished 2021 paper. And you can see that some of those problems were quite difficult. Some I didn't do, the only one I think I didn't do fully, and that will take a long time. So you have all the information now. I'm going to send you the recording of this, and you can go through this. Now there is also the 2020 paper, which we didn't do at all. So we don't have time for that. This is the last session that we did, and in those 4 sessions we covered only 75 problems, because 3 times 25. But I think that should be quite sufficient. 75 problems is quite a lot, and they had various types, all kinds of different kinds of situations. So in problem solving, guys, is you have to. The best thing to do is, you can't prepare for an Olympiad. You can't prepare for an Olympiad by saying, let me do this, and we'll have a question which is similar to that. Not like your metric paper. Right? Your metric papers and your school papers are really, if I may say so, very wishy-washy, because you remember some things and then you just reproduce it, at the final exam. Here, you can't do that. You have to think on each one of them, think on your own 2 feet, and try to figure out a method of solving the problem. But over these 75 problems, there are lots of ideas, lots of strategies, how to go around doing things. And I hope in this time that I had, I showed you how one goes around trying to tackle a problem, looking at the question, breaking it up slowly, and don't jump into the answer straight away, but understand the question, try to see what you can extract from the given information. And in many cases, you have to work towards equations, right? And if you can get to equations, then you can solve. In geometry, again, some of the ideas that we've had are similar triangles, which have got the sides are in the same proportion. Two triangles have got the same angles, then the sides are in the same proportion. And then there are a few results you have to know in geometry. But in most cases, they ask you questions on equilateral triangles and squares and so on. So we don't require too much of school mathematics to actually solve these problems, but there's a lot of thinking involved. Like for instance, here in this last problem number 25, we had quite a lot of, you know the meaning of 1005 factorial. You can understand what the question is, but how do you go around doing it? So there you have to think out a method of doing it and answering the question precisely. Okay, so with those remarks, I want to just thank all of you for coming. Make sure you go into the webpage and write down that you attended this session and any other session that you have attended, right? So that you can get invited to future sessions. All right, I'm going to actually stop sharing now. Or maybe I wouldn't stop sharing. Let me entertain questions first. Sometimes in the chat column, okay, somebody had, all right, there are no questions in the chat column. There are some comments. Somebody thanked me very much, said much appreciated. So let me just see who that person is. Okay, Matthew, or Aisha, right, okay. My pleasure, and Matthew also. Okay, Matthew says something. Thank you for everything that you have done for us, Prof. It was an honor and privilege to listen to your helpful lectures. I wish you a pleasant evening. All right, thank you very much for that, Mr. Hatting. I appreciate those good remarks. All right, hopefully we will talk again when you go into higher levels and we do other kinds of problems. So we might meet again, some of you. All right, so if you have any questions, you can remain behind and I'm going to now answer them. All right, are there any other questions? Oh, some of my good friends are here. Luke, I'm glad to see you here. I hope you benefited from this class and others. There are people who I've seen before. Are there any questions? Akil is somebody who I recognize. Renono, there are quite a few people who I recognize amongst this group of 25 people who have remained behind. All right, from Peter. Peter says, okay, Sutirtha, I will have a lovely evening. Peter asked me to do number 14 again. So let me go and look at number 14. Peter, put your mic on so I can see which one you were referring to. Oh, this one. This is the one that I struggled with.
Yes, sir.
All right. Okay. Okay. The answer is so easy, but the information that is given in such a way that it's very hard to get the answers. All right, let me do this again. I struggled with this myself because I forgot how to do it. Okay, the bottom line is that you got a guy who's traveling in the morning and afternoon. Right. Travels in the morning and in the afternoon. And he takes either a bus or a train in the morning, takes either a bus or a train in the afternoon. Now, further down the line, they say the man took the bus to work in the morning 8 times. Right, so if you put down here, if you put bus and train and divide this thing up, you see what he does in the morning and what he does in the afternoon. He took the bus in the morning 8 times. Right. If he goes to work in the and he came back by bus in the afternoon 15 times. So he came back 15 times. Right. Now, so this is a bus in the afternoon. Now, they say he came home by bus and commuted by train 9 times altogether. But they don't tell you how many times he took the train in the morning and how many times he took it in the afternoon. But we say, suppose he took it X times in the morning, then he would have taken it 9 minus X times in the afternoon, because altogether it commuted by train, morning, afternoon, 9 times. So all the pieces of information have been put together here, and that is what we've got. And the question is, how many days in the month did the man work? Now, you'll think, what is going on here? How do you get this thing? Are there any other pieces of information? There's no other piece of information. All right. So, important thing is that the number of days that he worked, number of working days, each day he makes 2 trips. Times 2. Each day he makes 2 trips. So the number of working days times 2 gives you the total number of trips. Is equal to the number of working days. Each day he makes 2 trips multiplied by 2. But we know the total number of trips he makes because we've got the whole lot here. Together, the total number of trips he gets is you travel 8 times in the morning, 15 times in the afternoon, X times here, 9 minus X. The total number of trips is the sum of all these. So when you add up all these, you get 8 plus 15 plus X plus 9 minus X. The X's cancel. 8 plus 15 is 23. And 23 plus 9 is 32. So the total number of trips, the number of days multiplied by 2 is 32. So therefore, the number of days must be 16. It's so easy, you know, the calculation is so easy because it's 8 plus 15 plus 9. Actually, it's 8 plus 15 plus 9. I don't even have to put X because that's the total number of times you travel by train. The total number of times you travel by bus is 23. The total number of times you travel by train is 9. So you could have said 23 plus 9, right? You either travel by bus or the train, gives you twice the number of days. So 23 plus 9 is twice the number of days. So the number of days is 16. Okay. All right, so let's get back. Is there any anybody else? Sorry, who asked that question? Who asked this question about the bus in the train? Peter.
Me, sir.
Do you understand it now, Peter?
Yes, sir.
Okay. Any other questions?
No, sir.
All right. Anybody else?
Yes.
Okay. Who is that?
Renono.
Renono. Yeah. Okay. Renono, tell me. Oh yeah. What is your question, Renono?
What is the quickest way to check if a number is prime?
All right. You're asking me another question. Okay. I'll tell you what I do. Let me share the screen. It is not easy to determine whether a number is prime or not. Right? But the quickest way, if you're not using the computer, oh, all right. So suppose I want to check that 1081, is that a prime number? Right? I know, because I know my numbers, I know that that is 23 times 47. All right. Now the way to get to that is you try all the primes from the beginning. You test only the primes to see whether a prime number goes into this. Take all the prime numbers, 2, 3, 5, 7, 11, 13, 17, 19, 23, and so on. And you check to see whether these numbers go exactly into this. But now the question is, how far do you go? You'll only go up to the square root of the number. Approximate square root, right? 1081 is, if you check it out, 1024 is 32 times 32. So you only go up to maybe 32 or maybe 33. So you test all the primes less than 33. Right? If none of those primes go into this number, then you can conclude that this is a prime number. Otherwise, you factorized it. So in this case here, when you come up to 23, you'll see you come up to 23 times 47. All right. So that is how you test it. This is one of my favorite pastimes. I can take any number. If you give me a number like 2157, I can tell you that's 3 times 719, and I know that 719 is the prime, because in my long years, I have a fairly good idea of what the prime numbers are. So I can factorize a lot of numbers into prime factors quickly, but it's not easy to do it. It's not easy to factorize, because you have to go right up to the square root of the number. If you've got a large number, like if you've got 997312 or something like that, right? You have to go to almost 1,000, because 1,000 times 1,000 gives you 1,000,000. So you have to go all the primes up to 1,000, and you have to know what the primes are and try them before you eventually come to this. So 312 is not a nice number, maybe 317 or something like that. But usually, but 3, there are quite a lot of multiples of 3, so you can get to that. You can eliminate very quickly. And once you divide by 3, then you can work out the other factors, because the other factor is smaller and you can try it out again. Okay, are there any other questions? I don't know to ask me a general question, but you wanted to know maybe about 2021. I told you 337 is a prime number. So there you only have to go up to the square root. The square root of 337, 18 times 18 is 324. So you only have to go up, or you only have to try these numbers here to see which of those numbers go into this. right? If none of those numbers go into this, it's a prime number. And it's very easy to eliminate quite a few, 7, and you just might have to try out by long division the others. Are there any other questions? All right, then everything of the best. I think the exam is 2 hours long, and I wish you everything of the best. I hope that you can get into round 3. I'll be very happy if you can do that. And I'm looking forward to seeing as many people as possible going to round 3. Akil says, thank you for the lessons. They were all very informative. Yeah, okay, I appreciate your comments, Akil. Thank you very much. Okay. Okay, thanks, Shriyansh and Jason.
So,
Yes, Jemima.
this is more of a general question, and I think you went into it at the end of the session. But
Yes.
what would your general advice be for, like, besides these training sessions, what would your general advice be for preparing for the round 2 next week?
Preparing for the, yeah, as I said right in the beginning, it's very difficult to prepare for it because people make up questions with some ideas and they make up questions. And usually the way to solve the problems, you use very basic mathematics. You've seen all the time, we've been using averages and sums and squares and so on, very basic mathematics. We hardly ever use anything which is very profound. So the mathematics that you use is not very profound, but the general principle I would say is you have to do as many problems as possible so that when you see a particular problem, then you'll say, hey, wait a minute, I've seen something like this before, and I remember that this is the way to do it. So let's try that technique, See, so yeah, that is as much as I can say. Like in geometry, to find areas, like for instance, when you're doing areas, let me just give you an example because I had a question here on areas, and I think it was this one here. Yeah. Can you see this? Question 12.
Yes, sir.
This is question 12 of problem of the 2020 paper, which we didn't do. Right? And I struggled a lot with this thing here, but eventually, you see, this is the problem. You've got a square. Each side of the square is divided into 3 equal parts, as is shown in the figure. And so what you have is each side is divided into 3 equal parts. So you've got a square, so all these are equal. All these are equal all around here, right? And then you draw this line going up to this first point, then you join this point here to that point, and so on and so forth, to create a new diagram. And in this new diagram, you know the area of these small squares here. This area is known. And the question is, what is the area of the original square? Now, if you do it using geometry or if you use algebra, there are lots of theorems that come along here, which makes this thing very complicated. Like, okay, let me do it. So this is, if you want to use algebra for this, and you say, well, I know the area of this square is 9. All right. So let me see whether I can get an equation. Right? I can call this, I need to find the side here of this with an unknown. Right? So I can say the square of that equals 9, and then I will know what that unknown is. So I tell myself, let me give a name to the smallest side in the picture. And I said, let's call this Can you see this picture? Question 12.
Yes, sir.
All right. Okay, so I give a name to the very smallest side in the picture. I'll call this guy here, I'll call him X. Right. Now, a theorem of geometry kicks in and this becomes 2x. The reason for that is these are equal. This is parallel. And therefore, the midpoint theorem says that this is x, this is 2x. But in any case, all these are equal here, and these are parallel lines. So this will be 3x, intuitively. But there are theorems in geometry which tell you why these are x and 2x and 3x. In fact, it is not even given that these lines are parallel. How do I know they are parallel? Again, there is a theorem in geometry which says that this whole figure here is a parallelogram. The reason being that this is equal to that. Opposite sides are equal. It's a square. So all these 9 sides are equal and they are parallel. Therefore, this figure is a parallelogram. Therefore, the other pair is parallel. So there are a lot of theorems like this. It becomes very complicated. So all these lines are parallel. And then how do you know that this is a square? That's another question you can ask. How do I know that this is a square? We just join some points. See? And again, why is it a square? If you look at this angle here, right? And you look at this big triangle here, this angle here is one of the angles in the big triangle, which is 3 by 1, a right angle triangle. And here also you got a 3 by 1 right angle triangle. So those two triangles are congruent. This triangle here, 3 and 1 on the sides, congruent. So if that angle is a dot, this angle is a dot. Right? But I know that this angle plus that angle is 90 degrees. See? And therefore, this angle here is 90 degrees. So now you've got a parallelogram with all the sides equal to 90 degrees. And like this now, you can eventually get to, like, now this is 3x, so this is 3x. Right? But the same reasoning, because now you've got a parallelogram. Now, so if this is 3x, so now you have, this is a square, and this square here has got the same area as that. So you have 9x squared. That's the area of the square, is given as 9. The area of the shaded square is 9. So therefore x squared is equal to 1. See? And the question is, what is the area of the original square? Right? And the area of the original square is this squared. And this is 3x here. Like that. And again, you get this is 3x. So the area of the original square is this squared. And that's using the Pythagoras' theorem, you can get the answer. Now, that is the problem. It took such a long time. But then I noticed the following. It took me a long time to notice the following. And I got the answer so quickly. And now, whenever I see this problem, I will always use this new method. I'm going to show you just now what it was. I told myself, look here. why don't I cut out pieces of this original square and fix it into this to create a larger square? Now watch. See, there's the original square. This is the diagram that we had. Then I took out this little triangle here, this part of the original square, and I moved it across to this side. Exactly the same triangle. I translated it to this side. And the same thing I did to this triangle here, I pushed it to this side here at the bottom. And then I saw that this red area, this is the same as the red area. And this thing here is the same as the blue area, the yellow area. So, in other words, the original square has been translated into this blue figure. It's just cutting and pasting, right? But the blue figure has got 9 of the blue squares, small blue squares, right? And those 9 blue squares, they are each area is 9. I'm sorry. The blue squares, you got 10 small areas, and each small area is 9. So therefore, the area that we're looking for is 90. By cutting and pasting, without doing any x's and 2x's and all that nonsense, I suddenly got a picture where I got 10 squares, which are exactly equal to 9. But, you know, in future, whenever I see problems like this, I'll cut and paste and see what I can do. So hopefully you have learned something from that exercise. Right? Like that now, each time you have a strategy, you will try something, you know. And the distance time problems, you've seen the way I've done it, you know. A lot of it is involving proportion. You'll never see, you haven't seen me using, you know, velocity and time and v and t and all those unknowns, right? And you can do, if you use algebra, you can solve those problems, but it becomes much more complicated. But you could use simple ideas to solve these problems. That is why they become problem solving and ingenuity. So very often in distance time problems, there are problems just involving ratios, you know, and when you use that, the solutions become very easy. So when you do all these problems, you will see that you learn certain ideas, and those ideas, you can apply it in other problems. And there's a good chance that quite a few of the ideas that you've done in the 75 problems will occur in other mathematics papers, because we've done, you know, quite a wide variety of types of examples. Does that help, Jemima?
Yes, sir, it does. Thank you.
Okay, no problem.
Thank you for watching this Mathematics Olympiad training video with Professor Pillay. Good luck for the second round of the Old Mutual South African Mathematics Olympiad.